This video is about multiplying algebraic fractions. Let's look at the question. Express the following as a single simplified fraction. So I'm like, yo, I see a fraction here and a fraction here, and I must multiply them. How do we multiply fractions? Well, pretty straightforward. It's the numerator times the numerator and the denominator times the denominator. So we could very much do that. 6c times 15w cubed. Well, 6 times 15 is 90. And then cw cubed. And the bottom, w squared times 2c squared. Well, 2 is the only coefficient, and then we can follow it off with w squared and c squared. And that's a pretty decent answer. And then we can simplify it. Well, on the top we have one term, 90 cw cubed. Since they're all being multiplied by each other, it's all just one term. And on the bottom we have 2 times w squared times c squared. Since they're all being multiplied, it's just another one term. So and we can say, oh, what's in common between both these terms? Well, we look at the 90 and the 2. We can divide both of them by 2. So 90 divided by 2 is 45. 2 divided by 2 is 1. Anything else in common? Well, look, there's a c on the top, 2 c's on the bottom. We can cancel out 1 c on both sides. I'll cancel out this c. We'll get rid of that 2, so there's only 1 c remaining. Let's look at the w's. W cubed, w squared. That means there's 3 w's on top, 2 w's on the bottom. We can cancel out 2 w's on both sides. So I'll get rid of these 2 w's. I'll get rid of 2 w's here, so we're left with just 1 w. And we can see what we have on the remaining. So 45w. So it's important to just be quite neat here. And on the bottom we have 1c. And that's our answer. And that's a pretty good way of doing it. But I think there's a better way of solving these problems. And the way we're going to do it is we're going to simplify our fractions before we multiply them. So how do we do this? Well, whenever we're multiplying fractions, the first thing we can do is we can simplify the left-hand side. So I'll write down left. So let's look at the left-hand side. So we have one term on the top, or one term on the bottom. Anything in common? No. Okay, let's go to the right-hand side. 15w cubed, 2c squared. Anything in common? Well, nothing we can divide 15 and 2 by, and then no letters in common. And then the beautiful thing about multiplying fractions is that you can simplify diagonally. So let's look at this diagonal here. So I'll say diagonals. 6c and 2c squared. Well, look at 6 and 2. We can divide both those numbers by 2. So 6 becomes 3, 2 becomes 1. Anything else in common? Well, there's 1c here and 2 c's here. We can cancel out 1c from both sides. I'll cancel out this c here, and I'll get rid of that c squared. Then, to keep things neat, let's just write out what we have so far. So on the left-hand side, we have 3 over w squared times, and on the right-hand side, it's 15w cubed over 1c. We don't need that 1. It's obsolete. Then we'll look at the other diagonal now. Well, what's in common? Well, I notice both diagonals have 2 w's in common. Let's cancel out 2 w's. So we'll cancel out 2 w's here. And if there's nothing remaining, don't leave it empty. Put a 1. And then we'll cancel out 2 w's here. So 3 w's, take away 2, we're left with 1 w. So let's see what we have left. On the left-hand side, we have 3 over 1 times, on the right-hand side, it's 15w over c. So we've simplified our left-hand side, right-hand side, diagonals, and then now we multiply. 3 times 15w is 45w, and 1 times c is 1c. That 1 is not really necessary, so it's just going to be 45w over c. Let's do another example here. So, step 1, let's look at the left-hand side. Anything in common with the left-hand side? Well, we have one term on top, x4, y4, and one term on the bottom, z squared. Anything in common? No. Let's look at the right-hand side. Z over x to the power of 6y. Anything in common between these two terms? No. Then we're going to look at our diagonals. So left, right, diagonal. Let's look at this diagonal first. Ooh, z squared, z. There's one z in common. I'll cancel out. I'll get rid of this z. If it's empty, just put a 1. And we'll get rid of one of the z's here. Let's write out what we have so far. X to the power 4, y to the power 4 over z times 1 over x6y. Let's look at the other diagonal now. Ooh, what's in common? Well, let's look at the x's first. There's 4x's here and 6x's here. Well, we can get rid of 4x's on both sides. So I'll get rid of all 4x's. If I have 6x's and I get rid of 4 of them, I have 2x's remaining. And here, there's 4 y's here and 1 y here. We can get rid of 1 y on both sides. I'll get rid of this y here, and 4 will turn into a 3. So let's see what we have now. So on this, we have y cubed over z times 1 over x squared. Sorry, I was not super neat there. Now we can multiply. So y squared times 1 is just y squared. Z times x squared is zx squared. And that's our answer. So simplify the left, simplify the right, simplify the diagonals, and then multiply. You can do these questions here. Next page. Express the following as a simplified fraction. So we have two fractions. We're multiplying them. We'll do the same thing. We're going to simplify before we multiply. Let's start with the left-hand side. Well, now here, how many terms do we have? Well, we have 3 terms, 3x, 2, and 3. Since the 3 and 3x and the 2 are separated by a plus sign, they're 2 separate terms. So when we look for things in common, it has to be in common with all 3 terms. Anything in common between 3x, 2, and 3? No. Let's look at the right-hand side. X, 1, and 3. We have 3 terms, x, 1, and 3. Since x and 1 are separated by a plus, it's 3 separate terms. Anything in common? No. Now let's look at the diagonal. Let's look at this diagonal here. 3x, 2, and 3. Anything in common? No. Let's look at the other diagonal. 3x and 1. Anything in common? No. Crap. So we've tried simplifying on the left, nothing. Tried simplifying on the right, nothing. Tried diagonals, nothing. Then let's just multiply them now. So 3x plus 2 times x plus 1, we can just write it like this. And the bottom, 3 times 3 is 9. And that'll be our final answer. It's a single fraction. Let's look at this example over here. So let's start with our left. So we have 2 fractions. We're multiplying them. Let's simplify before we multiply. So left-hand side first. 7, 2x, and 8. Since 2x and 8 are separated by a plus sign, it's 3 separate terms. Anything in common? No. Oh, gosh. How about the right-hand side? X, 4, and 14. Anything in common? No. Let me show you an example of when we could simplify. Let's say I put a 2x in front of this. So 2x, 4, and 14. We can divide all 3 terms by 2. So this would turn into a 1x. This would turn into 2, and this would turn into 7. So it'd be 1x plus 2 plus 7. 1x plus 2 over 7. But in this case, we can't. Nothing in common. So we've tried right. Let's go diagonally. Ooh, 7 and 14. I can divide both those numbers by 7. So 7 divided by 7 is 1. 14 divided by 7 is 2. Let's write out what we have so far to keep ourselves nice and neat. 1 over 2x plus 8 times x plus 4 over 2. Let's do the other diagonal now. Anything in common? Well, how many terms do we have? We have 2x, 8, x, and 4. Anything in common between those 4 terms? Crap, nothing in common. But, my friends, sometimes there's a little trick we can use. We can factorize. Can we factorize 2x plus 8 or x plus 4? Well, here, I notice 2x and 8 have a 2 in common. So I can write it out like this. 1 over, instead of 2x plus 8, 2's in common. I'll take it out. And x plus 4. And I'll write the rest of it. So now, since 2 is being multiplied by x plus 4, it's just 1 term in total. So 1 term, and then, so now we can say, oh, what's in common now? Well, x plus 4 is in common. Boom. Since there's nothing left, we'll put a 1. So we'll write out what we have. We have 1 over 2 times, 1 over 2. 1 times 1 is 1. 2 times 2 is 4. And that's our answer, okay? So in this case, we could factorize, and we noticed that both terms had an x plus 4. We could cancel them out, all right? Last page. All right, same thing. Multiplying algebraic fractions. Let's start with the left-hand side. How many terms do we count? 1, 2, 3, 4, 5. Anything in common? No. Let's go to the right-hand side. Anything in common between all of these 5 terms? Well, there are 3 x's here, but there's no x's at the 4 and the 25, so nothing in common between all of them. Let's look at our diagonals. All right. Let's look at this diagonal here first. 1, 2, 3, 4, 5. Anything in common? No, but let's try and factorize. I'll do on the side. X squared plus x minus 6. So this is a quadratic, so we're gonna multiply this -6 and add to 1. Plus x means 1x, so we're gonna add to 1. So what numbers multiply to -6 and add to 1? Well, -2 and 3. So it's gonna be x minus 2, x plus 3. And then let's factorize the other x squared minus 4. Well, x squared minus 4. This is an example of difference of 2 squares. Dots. Difference means subtract. Subtraction sign. 2 terms. Squares, they're both square numbers. What we're going to do is we're going to square root both terms. Square root, square root. The square root of x squared is x. Square root of 4 is 2. So it'll be x and 2, x and 2. One's going to be plus, one's going to be minus. So let's write that down. So x squared plus x minus 6 is now x minus 2, x plus 3. We'll deal with the other diagonal later. And this is going to be x plus 2, x minus 2. Ooh, what's in common? They both have an x minus 2. Boom. All right, let's keep it neat. That's nice and slow, so let's write what we have remaining. So x plus 3, x squared minus 25 times x squared plus 10x plus 25 over x plus 2. Let's look at the other diagonal now. How many terms do you count? Well, 1, 2, 3, 4, 5. Crap, nothing in common. But let's try and factorize. Let's start with the x squared minus 25. Ooh, there's a difference of 2 square numbers. Let's use our difference of 2 squares. Square root of x squared is x. Square root of 25 is 5. Open up 2 brackets. x5, plus and minus. It's the difference of 2 squares. And let's get the other one. Ooh, this is a quadratic, so we'll use quadratic factorization. So, man, I'm starving. X squared plus 10x plus 25. So we're going to multiply to 25 and add to 10. Oh, this is easy. 5 times 5 is 25. 5 plus 5 is 10. So 5 and 5. So x positive 5, x positive 5. So let's write down what we have. X plus 3 stays on top. X squared minus 25 is going to be x plus 5, x minus 5. This was x plus 5, x plus 5 from up here over x plus 2. Ooh, they both have x plus 5. We simplify diagonally. So on the top, we're left with x plus 3 times x plus 5. So let's just write that. Let's multiply them. We're going to leave them in brackets. And on the bottom, we're doing x minus 5 times x plus 2. X plus 2, sorry. And that's our final answer. We've simplified it into a single fraction.